Here we are looking at exponential equations in quadratic form. And so we're going to have to use some of our tools. And one of those that we've used before that we're going to need to use in solving these two examples that we're getting ready to go through is U substitution. So we've got a quadratic equation that involves the natural base. So we've got the natural base e raised to the power of 2x plus 2 times the natural base raised to the power of x equals 8. Well, let's first go ahead and set this equation equal to 0, if you will. Or maybe I should do this first. Let's say here that we're going to say that u is equal to e to the x. All right, now, so that would mean then I would have u squared plus 2u, using my u substitution, minus 8 equals 0. And so now I've got a quadratic equation. And I'm going to factor this thing. I'm going to draw two sets of parentheses here. I'm going to put a u and a u on the left side for the u squared. And my constant is negative. My middle term is positive, which means I've got to have a plus and a minus inside my parentheses, and I need two numbers that are going to multiply to negative 8 and add to positive 2, and I think that plus 4 and minus 2 should do the trick. Now we're going to set each factor equal to 0, so I got u plus 4 equals 0. Subtract the 4 from both sides. I got u equals negative 4. And then I've got u minus 2 equals 0. And add 2 to both sides where u is equal to 2. Now we're going to resubstitute the natural base raised to the power of x for u. So now I've got e to the x equals negative 4. And e to the x equals 2. And then we can take the natural log of both sides, and I'm going to bring it to a second column. So then I've got ln e to the x equaling ln to the negative 4. I can't take the log of a negative number. Well, I'll go ahead and do it like this. The e and the ln cancel, so I got x is equal to the ln of natural log of negative 4, but I can't take the natural log of negative 4. In fact, if you put ln negative 4 in your calculator, you'll get the message that says you're an idiot, you've done something wrong. Okay, so negative 4 is not a solution. But how about 2? So we've got e raised to the power of x equals 2. Let's take the natural log of both sides. So I got ln e to the x equals the natural log of 2. The ln and the e cancel, and we're left with x is equal to the natural log of 2. And if I go in and put into my calculator, perhaps I should do that. Let's see, I've got ln of 2, and that equals, rounded to the nearest hundredth, approximately 0.69. All right, well, that wasn't too bad. I kind of like these brain teasers, things where I have to dip back into my Reese toolbox for different things that I may have done before. And I know you do as well. One more. This time I got 4 raised to the power of the natural base, 4e, 4 times the natural base raised to the power of 4x to the 4th power of x, plus 8 raised to the power of 2x equals 5. Well, let's set my, that shouldn't be 8, that should be, no, that's 8e. I left out the e. I'll have to put that back in there. All right, let's see. I'm going to set u as equal to e squared. How about that? All right, and then that would mean that I've got, that would put this as e, well, I've got 4u squared x plus 8u equals 5. And let's subtract 5 from both sides, set this equation equal to 0. I got u squared of x plus 8u minus 5 equals 0. And we're going to factor this. Let's see. Well, my middle term is, my last term, my constant term is negative. My middle term is positive. I know I'm going to have a positive negative in there. And I got 4u squared. Oh, that should be x. Let me get rid of that x. There you go. All right, u substitution, e squared to e squared x. Let's see, I'm going to try 2u and 2u. And how about a plus 5 and minus 1 equals 0. Let's see, 2u times negative 1 be negative 2u, but 5 times 2u is positive 10u, 10u minus 2u, 8u. Yeah, that's it. Okay, let's set each factor equal to 0. Subtract 5 from both sides, so I got 2u is now equal to negative 5. U divided by 2 is equal to negative 5 over 2. 2u is equal to 1. U is equal to 1/2. And now let's resubstitute in our natural base raised to the power of 2x. So now I've got e raised to the power of 2x equals negative 5 over 2. I could really quit working on this because I'm about to take the log of a negative number, but let's do it anyway. Ln raised to the power of e to the 2x equals ln of negative 5 over 2, but I can't take the log of a negative number, so that's not going to be a solution. Well, let's work on the other. So we got e raised to the power of 2x equals 1/2. Let's take the natural log of both sides. So my natural base and the natural log cancel out. Then I've got 2x equals ln of 1/2. So that x is equal to ln of 1/2 divided by 2. So the x is going to equal approximately, let's figure that. Let's see, ln of 1/2 divided by 2 then is rounded to the nearest hundredth is negative 0.35. Negative 0.35. It is so nice when a good plan comes together.